Hi, this is Mr. Ward, and I'd like to talk to you about rotations. We're going to deal with some basic rotations, which are spins, which basically are going around a center of rotation. We're going to use the simplest center of rotation of the origin, 0, 0. Other points could be used, but I'm not going to do that for this video. And we're going to be rotating 90 degrees. We're going to go clockwise, which is around like that. We'll also do 90 degrees counterclockwise, and then finally we'll do one that's 180 degrees around that center of rotation at the origin, and then finally I'll do one that's 270 degrees. I'm going to steer clear of rotations that are 45 degrees or 30 degrees. For those, you're going to need some trigonometry, which is some math that you'll be learning later, but not right now. And there are some tools that I'll show you in one of the videos, some of those more advanced approaches in conceptual ways, but not in the mathematical ways that you would need with trigonometry. You would also need something called a polar coordinate system, which you can do in Desmos, but not right now. Right now, we're going to rotate 90 degrees clockwise around the center of the rotation. So what that means is if we think about this point here as the center of our rotation, I think we could pick this point. This will be the easiest one to think about. What's going to happen is this point is going to go 90 degrees around, and you can probably conceptually see that it's going to end up at 0, -5. So 5, 0 ends up at 0, -5. You might notice that those two numbers, 5 and 0, switched position, and then the 5 became negative. So what's happening is our new point, if we're going 90 degrees clockwise, what's going to happen is the x and y are going to switch positions, and the new y value, which was the x value, is going to become negative. So a quick way to make notes on this is you can say xy becomes y -x. So let's actually do this. I'm going to copy pasta my triangle here. Okay. And once again, it's got 4 points because I got to have a fourth point to loop back. So what I'm going to do is I'm going to take the 8, 5. I'll start with actually the 5, 0 to show how that works. So the 5, 0 is going to become 0, 5, and then the y needs to be negative. So there, I have rotated the 5, 0 to 0, -5. I'm going to do the same thing to 2, 4. That's going to become 4, 2, but I'm going to need it to be a -2. And, you might want to think about what quadrant this is as you're thinking of it conceptually. This quadrant is quadrant 4. And all of the y values in quadrant 4 are negative, and all of the x values are positive. So the x and the y change position, and the one that has to be negative because it's now in quadrant 4 is going to be y. We'll do the same thing with 8, 5. So 5 becomes x, the y becomes x, 8 becomes y, the x becomes y, and then it's negative. And there you have our third point. Now I have to first fix this one here. And now I will go ahead and connect the dots. And I have to scroll down a little bit to do that. There. So now we have rotated this triangle 90 degrees clockwise around the origin. In fact, I can make it clear that that has happened by plotting a little circle. I'm going to make a little circle that's centered at the origin. It's going to be, I'm going to say x squared plus y squared equals 25. And there, if you'll notice, it's gone through here and here. So this point has rotated along this. I could also set it here. That's a little trickier, but it's possible to do. So let's see here. I'm going to use, for that, to know how far this is going to be the distance here is the square root of the sum of the squares of 2 and 4. That's using the Pythagorean theorem, by the way. So I can just say 2 squared plus 4 squared, and I have that radius. Now, you don't need to understand how this circle thing works right now, but you might be curious about it, and that's good. But basically, I am squaring the radius, and the radius is, of course, the square root of 2 squared plus 4 squared. So, but the point is, the circle travels around here, all right? I could also prove it for this point. This point is at 8, 5, so I'll just change that to 8 and 5. And this point just swung around that circle. Now we're going to work backwards and go the other way. And what you're going to find is, I'll turn that off so we don't need to worry about that. When we go in the other way, in the counterclockwise direction, we're going to switch the x's and y's again, only this time the new x is going to become negative. So I'll copy my points again, and I'm going to be switching x and y, and the x will be negative because we're moving from quadrant 1. What's going to happen, it's not that it's become negative, it becomes the opposite sign. That would be a better way to think of it. So I'm moving from quadrant 1 to quadrant 2, and anything that is fully in quadrant 1 has a positive x and y. When it gets to quadrant 2, it's going to have a negative x and a positive y. So if x and y swap positions, the new x is going to be negative. Okay. Now, it might be easiest to see that the 5 is going to end up, the 5, 0 is going to end up at 0, 5. That one is not in a quadrant, so we don't worry about the opposite sign of the 0. Let's actually deal with that one first. So that becomes 0, 5. So x and y change positions. We don't worry about changing the sign of 0, but we do worry about changing the sign of numbers that are not 0. So 2 becomes a new y, 4 becomes a new x, but it's in second quadrant, so the 4 has negative. I'm moving counterclockwise, so the new x is going to change signs. So that'll be a negative 5 and a positive 8. And I'll fix this last one. Oops. Hit the wrong button. Okay, negative 5, comma 8. So what's happening here is whatever my x and y are, x and y are swapping, and the y is the old y, which is now the new x, is changing signs. Okay, so if I were to rotate one more time clockwise, I'll go ahead and give this line so it's a triangle-y thing. If I were to rotate one more time counterclockwise, we're going to end up switching the x's and y's again. So that negative 5 is going to become the new. I'm having a visit from our new kitten. He wants to be on the keyboard. I'm going to set him aside. Okay, there we go. So that negative 5 becomes the new y, and the 8 becomes the new x. However, we're not going over to this quadrant. We're going to this quadrant. That 8 changes sign too. So there it is. Okay, so this point, which is currently to the left 5 and up 8, is now going to be to the left 8 and down 5. Okay, so that's what's going to be happening. You're going to just keep reversing the x and y positions and changing the new x's sign. All right, let's deal with 180 degrees though. Okay, with 180 degrees, we're going to take this and we're going to rotate it all the way around. Now this 5, 0 is going to rotate all the way around to negative 5, 0. So you might notice that the x and y stay in the same position, but you notice that the 5 changed signs. So the x changed signs. If I moved this point, which is currently to the right 2 and up 4, it's going to end up being over here to the left 2 and down 4. So it's going to still have the 2 and the 4, but they're both going to change signs. So you're going to keep the x and y in the same position. They're just going to change signs for a 180-degree rotation. Now, you might be wondering, well, which way, Mr. Ward? Are you going clockwise or counterclockwise? It doesn't matter, because going around 180 this way is the same as going 180 degrees this way, because the circle, we're going around a circle, which is 360 degrees. So all I have to do is just change. I've just copied my original triangle, and I just need to change the signs of all of these. If they were negative, I'd be changing them to positive. But right now they're positive, so I'm changing them into negative. Zero doesn't have a reverse zero, and so I have now rotated 180 degrees. Let me go ahead and set that up with lines, and we have our triangle. So we've rotated the object 180 degrees around the origin in either direction. It doesn't matter. Okay. One final rotation to consider with this. We're going to rotate 270 degrees clockwise around the center of rotation at the origin. So if I'm going 270 degrees, you might think in terms of each quadrant I switch to being a 90 degree. So 1, 2, 3, and you're going to end up where you would end up with a counterclockwise 90 degrees. So 270 degrees around is the same as 90 degrees the other way around. So I'm doing these in 90-degree chunks. So you can use that to come up with a simpler rotation. So this 270-degree clockwise around the center rotation, I take the clockwise rules. So I could do the clockwise rules 3 times, or I could do the counterclockwise rules once. And the counterclockwise rules, I'm going to switch X and Y. And if you forget what's happening here, you can just switch what X and Y. You can analyze what quadrant you're in. So I'm switching all of them. And I tend not to memorize this stuff. I tend to just analyze what's going to happen. So I've switched X's and Y's. But if I'm going around here, I'm going to end up with X values that are no longer positive. So what I need to now do is change all these X values into negatives. 0 stays the same. And now that sound you're hearing in the background is the cat attacking anything it can attack, because he is only 6 weeks old. So there we go. I have moved this triangle 270 degrees around clockwise, which is the same as 90 degrees around counterclockwise. And I'll turn off my previous 90 degrees counterclockwise so you can see what's happened. That's right on top of that same triangle. Okay, so I'll give it lines, and then we will just quick recap of things. There we go. Okay, so just to recap, if you want to rotate, number one, it's going to keep the same shape. It's going to be congruent. It's just going to rotate its orientations around a center of rotation. So in rotating clockwise or counterclockwise, you're going to switch the X and Y positions. So X becomes Y and Y becomes X. If you're going clockwise, the new Y value changes its sign. If you're going counterclockwise, the new X value changes its sign. You're switching X and Y. If you forget which it is, just analyze what the signs are going to be for the coordinates in whatever quadrant you're moving to. So if you were in this quadrant over here where X is positive and Y is negative, and you're going to quadrant 1, both are going to be positive. So you're going to switch X and Y, and both will be positive. If you were going clockwise into quadrant 3, where both X and Y are negative, you're going to go from a situation where X is positive and Y is negative to X is negative and Y is negative. So you'll switch the X and Y, and the X changes its sign. So you can reason this out if you forget the basic rules. And that's one of the most important things in mathematics, is not just having a body of rules that you follow, but a practice of problem solving and analysis that you use to build your understanding. Because there are simply too many rules to just like hold in your head all the time. And quite frankly, the rules follow a logic. And if you can understand the logic behind them, the rules end up making more sense. The 180-degree rotation, you're simply going to change the signs of both X and Y. So if I were here and I wanted a 180-degree rotation, I'm going to end up here. So all of my X's and Y's, so like this point here, is going to end up here. And so it goes from 4, -2 to -4, 2. So this is 100, these two things are 180-degree rotations of each other. It matters not which direction you're going in, you're just doing 180 degrees. And finally, the 270 degrees, or maybe 540 degrees, you just need to figure out how many 90-degree chunks you went in and see where you end up in. 270-degree rotation in one direction is a 90-degree rotation in the other direction. Okay, I hope that helps. And in my next video, I will give you some practice problems.